Organic chemistry has a way of asking how a process occurs. This explores a step beyond inorganic chemistry, where reactions are just made. In this video, I will explain how alkyl halides react with bases through an E1 mechanism. Understanding mechanisms are incredibly important. Without understanding the mechanisms, it would be like a baker showing me all of the ingredients of an apple pie and telling me to just mix them together in a bowl. But that doesn't explain the process in sequential order. However, a mechanism can show how a reaction occurs so that it's practical in use, and scientists can better predict how exactly every step of the reaction occurs. Here's a brief rundown of what will be covered in this video. The E1 mechanism, including a rate law and reaction coordinate diagram, as well as several examples to follow. Hopefully, this video will give a clearer understanding of the mechanisms of the E1 reaction. So here we have an alkyl halide reacted with hydroxide. E1 mechanisms happen in several steps, so it's also called a stepwise reaction. The halogen must first leave to form a carbocation. Because of the positive charge now present on the carbocation, it can now be deprotonated by this hydroxide. Now I'll draw in the beta hydrogen, which this bond is now free to come and form into a double bond. Essentially, the electron pair can come over to get rid of the positive charge by forming this new pi bond. Now I'm going to go ahead and draw the products of it. Now we can go ahead and try to find the rate law. For E1 mechanisms, the first step will always be the rate determining step because it is the slowest one. So if you think about it, it takes a lot more energy to go from a neutral atom to two charged particles. Thus, the first step is the slow step, and this is only involving the alkyl halide. So the rate law would be K times the alkyl halide. Now we can go ahead and draw the reaction coordinate diagram. So first we'll go ahead and draw where our reactants would be and our products. Now notice the products I've made higher than the reactants because in the E1 or any elimination reaction for that matter, it starts with 2 sigma bonds and you gain a pi bond after losing the sigma bonds. But the starting material would then end in a higher energy than it began. As the E1 is a stepwise mechanism, it has its transitions and intermediate states. So go ahead and draw that in. I thought it'd be helpful to keep the reaction coordinate diagram on the same slide as the mechanism so that you can go ahead and take a look and visualize the intermediate. Now we'll go ahead and move into some examples. So here we have this molecule and it's going to be reacted with hydroxide. For the purposes of this, we're going to just assume that hydroxide is a weak base. So, like the E1 reaction, the first step has to be the bromide coming off and forming a new carbocation. I'm going to go ahead and draw a couple hydrogens. Now, when determining which hydrogen to deprotonate, you must consider how stable the new product would be. Remember, for carbons, the more substitution, the greater the stability. So it makes most sense to deprotonate to this hydrogen right here. I'm going to go ahead and redraw this bond so that this hydrogen and these extra electrons can go and form a pi bond right here. So now our product looks like this. And this, remember right here, makes for the most substitution. Once again, when writing the rate law, the first step is always the slow step and the rate determining steps, because it takes greater energy to go from a non-charged atom to two charged particles than to go from two charged particles to back to a non-charged one. So the rate law is equal to K times this molecule and just that one, which is, again, why it's an E1 mechanism or a elimination unimolecular. Sorry, I ran off the page there. And the reaction coordinate diagram, of course, would look something like this, with starting materials lower than products, and then including an intermediate and transition state. So I thought to wrap up, I could include some key things to remember about the E1 mechanism. An E1 is a stepwise reaction, so the first step is always the slow one and the rate determining one. As products are higher energy than starting materials, this is an endothermic elimination reaction. As once again, it takes more energy for a neutral atom to break into two charged atoms than for two charged atoms to form a neutral one. These can be helpful concepts to remember when making the rate law and also drawing the reaction coordinate diagram. Thanks for watching this video on E1 mechanisms. Hopefully you're one step closer to understanding how to make your metaphoric pie.